11-7. Again, this is part 2, so this is on the back. Number 7, we're back to having a triangular prism. Remember, volume is area of the base times the height of the figure. So if you're looking at this triangle here, really doesn't matter which one you focus on, whether you focus on the left or the right. The right has the visible 90, which is how we know this is a 90. Base and height have to meet at a 90. So that 28 is my height. I don't have my base. When you're missing a value of a right triangle, we use the Pythagorean theorem. We're going to take this 32.5 and stretch it over here and make that our hypotenuse. And a squared plus b squared equals c squared. Run your formula. You get approximately 16.5 as your base. Plug that in. So area of the base is 1/2 base times height. And you get an area of a base of 231 units. That is only half of your formula. The other half is the distance between your bases. Our bases are triangles, so the distance from triangle to triangle is 31 units. You plug that in and you get 7,161 kilometers cubed. Number 8 is back to having a trapezoidal prism, where you're going front trapezoid to back trapezoid. If you remember, we talked about in 11-5, the very first page of how to identify what type of figure you're dealing with. Your bases must be parallel and you look for the odd shape out, which is how we know the trapezoids are bases. Area of a trapezoid, which I just went over in the last video, 1/2 times your height times base 1 plus base 2. Well, if you are looking at this thing, it gives you base 1 of 25. It gives you base 2 of 39.4. It does not give you the height. It gives you that nice pretty 90, but it doesn't actually give you a value for that. And it gives you our slant over here, but it does not give you this. So we are going to draw a triangle in, if you can see that. There's our right triangle. That's our missing value x. Now, here comes the fun part. So we're gonna transfer over to paper, and that way you can actually see what I'm trying to do here. So you've got, this is gonna be another one of those really pretty drawings, by the way. You've got a trapezoid where you're told that this part is 25, this part is 39.4, and that your slant is 30.6. And you are creating a right triangle right through here. Well, this is what you need, but you also need this part. If you focus, if this whole thing is 39.4 and this 25 runs parallel to that, you're going to do 39.4 minus that 25, and that gives you that this base is 14.4. Yeah. So from here, run your Pythagorean theorem. X squared plus 14.4 squared equals 30.6 squared. And you end up getting 27, or approximately 27. So that ends up being the height of your trapezoid. So we come back over here, we put 27 in the box, in the bubble, it's not a box, and then plug what we know into our formula. So 1/2 times our height times base 1 plus base 2, and that gives us a base area of 869.4. Then you need your second piece, which is the height between the bases. So you are going back over here, trapezoid to trapezoid, which is 35. So plug that in and you get 30,429 centimeters cubed. So again, not really that complicated, just these back two take a little more work, and that's just Pythagorean theorem, which you should be able to do in your sleep at this point. Now we have cylinders. Cylinders are a piece of cake. You're dealing with volume equals pi r squared h, where r stands for radius, h stands for the height of the cylinder. I mean, you're going to get a couple numbers and you're going to plug them in. It's really easy. So on number 9, for example, I'm up here. Number 9, 18 is your radius. Your height is 15. And you plug that information into your formula, plug it into your calculator, and you get 15,268.1 inches cubed. You literally cannot get any easier than this. 10. 10 just takes your thought process of, all right, that 11 is a diameter. We very rarely need that diameter divided by 2 to get your radius of 5.5. That is quite literally the hardest part of that problem. And then understanding that 21 is the height, meaning height between base to base. Plug it in, you get 1,995.7 meters cubed. Easy peasy. 11 and 12 are your application ones, and those are, slightly more time consuming, have a little more thought process involved. Number 11, a cylinder with a 2 centimeter diameter. That is something you need to know. Is drilled through the triangular prism shown on the left. Find the volume of the prism. So what you're going to have to do, because you've got a cylinder taken out, you've got to find the volume of this triangle and then subtract the volume of that inside cylinder. It's not there, therefore you cannot fill it up. It can't be a volume. So we're going to run the same formula that we've been running the entire time. Big B times H. Our base shape on this one is a triangle. If you look, and I do mean look, because it's really small, your 90 is right there. Base and height meet at a 90, so your base is 5, your height is 5. Really, really easy. So you're going to have to do 1/2 times base times height, and then this 14 is the height of the figure, meaning base to base. So triangle to triangle, this distance right here is 14. So that's the volume of the triangle. You get 175. You can step it out if you want and just write out step by step, and that way you do not get confused and then get that number. I just wrote it all out in one go. Then you have to subtract the volume of the cylinder. Your cylinder, if you remember, the diameter was 2. Do we want the diameter? No, we do not. We want the radius, which is half of that, so the radius is 1. So you're going to subtract pi r squared times h, where our r is just 1. So essentially you're doing 14 pi. But anywho, that gives you 43.98. Subtract that, you get 131.02 centimeters cubed. So just pay attention to your problems. Number 12. A diagram of Eric's pool is shown on the left. He plans to fill his pool to a depth of 4 feet with a garden hose that has an 80 cubic feet per hour flow rate. How many hours will it take to fill the pool? So you've got to find the volume of the pool and then do a unit conversion. So much fun. So we come back over here. What is different? What you need to pay attention to is that the pool itself is 4.5 feet tall, but it tells you in the problem, he's only filling it to 4 feet. So take that 4.5 that you're given and cross that out because you don't need it. You need 4. Well, it's a cylinder. A cylinder is, the volume of a cylinder is pi r squared h. You need r. We're given diameter. Diameter is 27. To move to r, you divide by 2, which gives you 13.5. That's your radius. You plug that into your formula. So V equals 13.5 squared times 4. I forgot a pi in there. Pi times 13.5 squared times 4, which gives you a volume of 2,290.2 cubic feet. That's how much water fits, well, that's how much water could fit in your pool if you filled it up to 4 feet. Now, what you've got to do is you've got to factor in that the garden hose fills it at 80 cubic feet per hour. So you divide the volume by how fast, and that gives you, or how much per hour, and that gives you how many hours it's going to take. So it gives you 28.6 hours. So just kind of pay attention to what it's giving you versus what you want. It gives you per hour. You're looking for hours. Just, I mean, really, it's just a paying attention kind of problem.